Okay, in this video I'm going to talk about naming with polyatomic compounds. Polyatomic compounds contain a polyatomic ion. A polyatomic ion is a group of elements that are stuck together in a molecule, and that molecule has an overall charge. That molecule then can participate as part of an ionic solid, and so really all of these are ionic solids. They're all ionic crystals, where most of the polyatomics are the negative part, the anion of the crystal. So some polyatomics. Probably by the end of this course, just through practice, you should know the ones I'm about to write out. Nitrate. You wouldn't normally put the 1 minus. I'm just putting it there so that you can see what the charge on it is. That one's nitrate. Carbonate. Oops. Phosphate. Sulfate. So 4, 2 minus. Maybe chlorate. Sorry, this was phosphate. Sulfate. You might know chlorate. I'm going to show you in another video a trick for remembering all of these common ones. It's sort of fun, sort of easy, but as I know a lot of other teachers that would suggest to you, just keep using them, do all the practice you're supposed to do, and then sooner or later these ones you'll use so often that whether you try to or not, you'll memorize them by the end. For this unit and for this course, we will largely give you a copy of what all of these are so you don't have to remember them. But in the end, we're working towards having all these basically memorized because they do come up enough that it's worth knowing them. Naming with polyatomics is essentially the same as naming for ionic compounds, except we're going to use the name of the polyatomic ion at the end of the compound. So when you see a polyatomic like SO4 here, or CO3, or PO4, then you should be able to, I did want to include one more common one. The one positive one you're going to run across somewhat commonly is NH4+, and that is ammonium. Sorry. Anyways, for naming these things, you're going to name them just like an ionic compound. We have to remember multivalences and that kind of stuff. But in the end, what we're going to do if we recognize that we've got this group of atoms like SO4 or CO3 is we're just going to throw the name of the polyatomic ion in the place of the nonmetal. So it's pretty straightforward. CuSO4 is an example. So Cu, we go to our periodic table, look up, we'll see it's copper. And if we're smart and we check, we're going to see copper is one of those multivalent ones. He can be a +1 or a +2. So we need to be careful here. We'll see he's paired up with sulfate. And you'll notice I've left a space in between the two things for my Roman numeral, but I don't know if I'm going to be using a 1 or a 2. If I look at the compound and don't think too hard, I might think it's 1, or worse than that, I might think it's 4, but if I'm careful, I'm going to see that it's 2. Let's see why. Sulfate, if I look it up, is 2 minus. So this copper, which by the way at the end ended up in a 1-to-1 ratio with the sulfate, so this is going to end as 1-to-1, has to have some charge up here that's 1-to-1 with 2 minus. So a 1-to-1 ratio is the same as a 2-to-2 ratio, so this would be 2 plus. So this is copper 2 sulfate. A little bit of a tricky one to start there. Sodium, in the next example, is paired up with carbonate. And I don't need to start worrying about my reverse crossover or any of that kind of stuff because that sodium has a charge of +1 in it. That's the only valence it can take on, so I don't need to. In fact, I can't include the Roman numerals. It would be wrong to. So this is simply sodium carbonate. Again, you're looking up that CO3. For now, you're looking up off a chart that we've given you, but after you've done this enough, you'll start to know, especially carbonate, sulfate. Those ones you'll see all the time. All right, iron, and that's, if you look PO4 up, you're going to find out that it's phosphate. So this is iron phosphate. If you go to the periodic table, you're going to see iron is a multivalent metal. It could have been +2 or +3. So that's a little bit tricky. So we're going to throw our Roman numerals in here, and we're going to leave ourselves a space, and we're going to go back and figure out which one it must have been in this case. Phosphate, from your list, you should see has a charge of 3-. So if that's being paired up with an iron, and then what we ended up with down here was a 2 and down here up here was a 3, we reverse the crossover, we see the 3 came from that 3, so this 2 must have been a 2, so this is iron 2 phosphate. And the very last example here, now we have the polyatomic out front instead of at the back, so the polyatomic in this particular case is going to take the name of the metal or the cation, and so this one is called ammonium chloride. No need to specify any sort of valence here or anything like that because ammonium is always +1. So there it is. Naming polyatomics is essentially the same as naming ionic compounds, with the same tricks associated with the multivalent metals that can be a little tricky, but beyond that, you just have to have a list or have some way of looking at what this SO4, what this CO3, what this PO4 means. I sort of gave you this ones. If you're looking for a list of, what is this, 1, 2, 3, 4, 5, 6 to memorize, these are probably the best 6 to memorize. But like I said, I'm going to do another quick video right now about a little trick to help you remember these, well, the top 5 here anyways.